Hello world, this is Mike with Backwards Machining. Just an update as to what trouble I've been getting into. So, I made I call it my Redneck pool heater. I guess you could call it many different things. It's either that or the Mickey Mouse pool heater, whatever. I used to have a Hayward propane pool heater for my pool, but it used so much propane it was absolutely insane. So I ended up messing around, just trying to have a little bit of fun and get some functionality out of this. I'm trying to make a wood fired type of heater. Now I'm going to walk you through concept, design, all that crap. So try to follow along, see if any of this makes sense to you. This is how it starts. So if you ignore the back plate, this is the first plate. This hole right here that I've highlighted in green is the input hole. This hole is the output. Now what you have to envision is there's going to be 2-foot pipes going from each one of these holes to another ring behind it. That would be this ring. Now this ring will not be facing the way it's facing, it'll be facing outward. But the point is, I wanted you to see what it's actually doing. So if you have a pipe from this hole to this hole, it will force the water through to this hole and then back out to this hole, and then so on. And it will force the water to keep going in one direction until it goes through all of the pipes, until it comes out. The reason I did that was to try to maximize the heating efficiency. You know, rather than let it go through all the pipes at once, it would be, better to try to heat the water this way. And just, my opinion, I'm not thermodynamically, inclined or educated here, but concept seems to make sense to me. So, that's what I did. So, this one here puts it into a little different perspective. Now this is the two plates mixed. So this hole shoots to this hole, this hole, this hole, all the way around until it finally comes out. Okay, so now that you've seen that, this is the first plate that you saw, the input plate, I'll call it plate 1, whatever. This is, I'm not sure if you can see the mouse cursor with this program, I'm assuming not, but anyway, you can see the input and the output, and you can see all the pipes and the channels. Now this is going to get covered with a metal plate over the top, and then that plate is going to be welded closed. This is a picture of the unit completed. Now you can see the two brass fittings at the top, the input output, and each one of these tubes is approximately 2 feet long, very thin wall tubing. This is the front view, how I have the hoses set up, trying to block it from the fire. Obviously, this is just a prototype, so don't take this to heart here, because I really am just kind of screwing around with this design. As far as the machining went, it actually was easy. I used steel, which I know isn't the best idea because of rust. Even the tubing itself, I ended up using I had a greenhouse one of those cheap greenhouses for, I got my wife, I don't know, for Christmas or whatever, and she only used it for about a month and then she took it down. But it had this really thin wall green painted tubing, so I ended up using that, and it seemed to work okay. Obviously this thing is going to rust itself inside out in no time, so it's not a long-term type of thing. This was more of a concept. And finally, I mean, this is basically me using the heater. The pump I have in my pool, I didn't actually, the picture I had of it for some reason disappeared, but it's a good sized pump that attaches right to the garden hose. So it's pumping the water from my pool to this and then back to the pool. And the problem is, though it's a decent sized pump, it's just not strong enough for all. Basically, I think these hoses are 25 feet each, so it's trying to push a lot of water over a pretty good distance, and one pump's not cutting it. I do have two identical pumps, so I bought a Y hose off of Amazon. I'm hoping that'll be in shortly, and I'm going to give that a shot. Now the water coming out of this heater, I haven't actually built up a very big fire for this yet, because I've just been screwing around. But the fire you see here, the water coming out of the heater was approximately 100 degrees. So the water going in was 74-ish. So it was doing its job. However, the output of the water, it wasn't as substantial as it would need to be to actually do any kind of, real heating. It just wouldn't work. My pool, unfortunately, is made of aluminum, and as everybody knows, aluminum is great for dissipating heat. Now in electronics, that's awesome, but for a swimming pool, not so much. Because every night when we have a cool night, my pool cools right down, and the next morning it's back to being freaking freezing again. So in any case, this is what I've been, dilly-daddling around with. Figured I'd show you guys. You can get a laugh out of it. But alright guys, hope everybody's doing well, and we'll catch you later.